So here I've got an example where I haven't actually done the graph yet. I've just given the equations and the boundaries and asked to find the area between the curve that is enclosed by all of these equations. So let's do a quick sketch. The sine graph I'll do in red, and the sine graph looks like this between 0 and pi, and we're not going to go beyond pi over 2, so we're looking at an area that goes between 0 and pi, and we know it goes up to 1. So here's my sine graph. The e to the x graph is an exponential graph that looks like this. It goes y equals e to the x. Sorry, that's x to the x that I wrote there, e to the x. And notice these graphs don't intersect, but we do know that we want to find the areas bounded by all 4 of these. So x equals 0 is this one right here, and x equals pi over 2 is this line right here. So the area in between all 4 of these is this area right here. So that means the green is definitely on top, and the left and right bound are already defined. We're going from 0 to pi over 2, and the function on top is e to the x, and then we subtract the lower function, which is sine x, and we're integrating dx. In other words, we're adding up all the areas, making these little rectangles, if you can imagine, and they have a width of dx. I'm just going to remind you of that because of the next examples that we're going to talk about. So let's do the integrals, and the integral of e to the x is just e to the x. It's a great one. The integral of sine is cos x, and I need to make this a positive if I want to get a negative sine x out, and I'm going to integrate that between 0 and pi over 2. So plugging in pi over 2, I get e to the pi over 2 plus cosine of pi over 2 minus e to the 0 plus cos of 0. So evaluating these, I'm going to leave this one in exact form. Cosine of pi over 0 is 0, so that disappears. This is equal to 1, and cos of 0 is also equal to 1. So that means that my final area is e pi over 2 minus 2. And you could change this to a decimal if it was an applied problem, but I would just leave that as it is. So we're going to do one more example in the next video.